Look at the seam of what you're wearing. It doesn't matter what it is, a shirt, a jacket, a pair of jeans. Find the seam, the place where two pieces of fabric are joined by thread, passing through a needle, stitch by stitch, until the garment holds its shape against your body. Someone had to invent that, not improve it, not refine a technique someone else had started. Invent it, the concept that two pieces of material could be joined with thread passed through a hole small enough to control the stitch, creating a sealed garment that traps warmth against the body instead of letting it escape at every gap. The person who first solved that problem left no name, no face, no language, no written record of any kind. What they left is a needle made from a bird bone, found in a Siberian cave 50,000 years after it was made. And something stranger still. The needle was found in 2016 in Denisova cave, in the Altai Mountains of Russia. It is 7.6 centimeters long. It is made from the bone of an unidentified bird, hollowed and shaped and polished until smooth. At one end, there is an eye, a hole drilled through the bone with a precision that archaeologists still study. The needle is intact. After 50,000 years in the ground, it could still be used. When archaeologists found it, they described it as the most ancient sewing needle in the world. But the question that makes the needle strange is not its age. It is who made it. The Denisova cave is not a site associated with Homo sapiens. It is not a site associated with Neanderthals. The species that lived in that cave, that left that needle, that sat in the dark of the Altai Mountains 50,000 years ago and worked a bird bone into a tool precise enough to thread, is a species that no scientist knew existed until 2010. We know almost nothing about them. We know them from fragments of bone and from what their DNA tells us they were. The needle tells us something the DNA cannot. In 2010, a team of geneticists led by David Reich at Harvard University sequenced the genome of a hominin recovered from Denisova cave. Not from a skull, not from a jaw, but from a single finger bone. The bone was the size of your fingernail. The DNA it contained was enough to sequence an entire genome. What that genome showed stopped the team. The individual was not Neanderthal, not Homo sapiens, not any species previously identified in the fossil record. It was a distinct lineage, a sister group to the Neanderthals, diverging from a common ancestor with them roughly 400,000 years ago, but entirely separate from both Neanderthals and Homo sapiens for the entire span of recorded prehistory. Reich's team published the paper in Nature in 2010. They called the new species Denisovans after the cave. The entire species, its existence, its range, its evolutionary history, was inferred from the genome extracted from a fragment of bone smaller than a coffee bean. And the genome did something else. It showed that Denisovans had interbred with Homo sapiens. Not once. People from Melanesia, Papua New Guinea, the surrounding islands, carry 4 to 6% Denisovan DNA in their genomes today. Populations across Southeast Asia and the Pacific carry measurable fractions of it. The two species met. Something passed between them, and 4 to 6% of it stayed. But here's where it gets stranger. In 2019, Katarina Duca and colleagues at the University of Oxford published a detailed chronology of Denisova cave in Nature. Using radiocarbon dating on bone artifacts found at the site, Duca's team placed the earliest Upper Paleolithic objects in the cave, animal tooth pendants, stone tools, bone implements, between 43,000 and 49,000 years ago. The needle fits within this window. 50,000 years old, give or take the margin of the method. What the dating tells us is that the needle was made before Homo sapiens arrived in force across Eurasia. Before the cultural explosion of the Upper Paleolithic that produced the cave paintings of France and Spain. Before the tools and ornaments that we typically point to when we describe the beginning of modern human behavior. The Denisovans were there first. And they were making things. The implications of the dating are not subtle. Everything we point to when we describe the beginning of modern human behavior, the cave paintings of Lascaux and Altamira, the bone flutes, the carved figures, comes after the needle. The Denisovans were not imitating anyone. There was no one to imitate. They were originating. A sewing needle is not a simple object. It requires a sequence of decisions. Choosing the right bone, understanding the grain of the material, shaping the shaft without splitting it, drilling an eye small enough to control thread without weakening the needle at its most stressed point. The technology implies prior knowledge of thread, of fabric or hide, of the garment it was meant to produce. The needle is the endpoint of a chain of invention that we cannot see, because nothing else from it survived. What survived is the needle, intact, after 50,000 years. This is not a story about something that happened far away and long ago. It is a problem the seam of the clothing you are wearing right now is still solving. To make that needle, you have to understand what you are solving for. Cold kills fast. At -40 degrees Celsius, the temperature that descends on the Altai Mountains in winter, a body loses heat faster than it can generate it. Draped animal hide provides coverage, but not seal. Heat escapes at every opening, every gap between the material and the body. A garment that is fitted, where pieces are cut and joined to conform to the body's shape, sealing at the wrists, the neck, the ankles, changes the physics entirely. It creates a microclimate between the skin and the outer layer that the body itself maintains. The difference between draped hide and a sewn garment is not comfort. It is survival. The person who threaded that needle for the first time was not making a craft. They were engineering a solution to a problem that killed without it. They understood, through observation, through loss, through whatever passed for knowledge in a species we cannot interview, that the cold could be defeated if you could seal the gap between the body and the material covering it. The eye of the needle is where that understanding became physical. In 2014, geneticist Amelia Huerta-Sanchez and colleagues at the University of California, Berkeley published a study in Nature that identified something unexpected in the Tibetan genome. Tibetans carry a variant of the EPAS1 gene, a gene that regulates the body's response to low oxygen, that allows them to live and function at high altitudes where most humans would suffer severe physiological stress. The variant is rare almost everywhere else on Earth. When the team traced its origin, the EPAS1 variant in Tibetans was nearly identical to the version found in the Denisovan genome. It was not a Homo sapiens innovation. It had been passed through interbreeding from a Denisovan population to an ancestral Tibetan population, and then selected for in the generations that settled the Tibetan plateau. The Denisovans are gone, but their engineering is still running. The needle was carved from bird bone. The modern sewing needle is stamped from stainless steel, 0.3 millimeters in diameter, produced by machines that make 10,000 per hour. The material is different. The principle, a shaft, an eye, a thread, a seam, has not changed in 50,000 years. The bone is different. The solution is always the same. And the EPAS1 gene that helps a Tibetan climber breathe at 8,000 meters today is a Denisovan solution to a Denisovan problem, running in a human body that the Denisovans never met, solving a problem they solved before any Homo sapiens had tried. The designer is gone. The design is still in production. Look at the seam again. The thread passes through the eye of a needle. The needle creates the join. The join creates the garment. The garment keeps the body alive in cold that would kill it in minutes without it. That chain, eye, thread, seam, warmth, survival, was worked out by someone whose name we do not know, whose face we cannot reconstruct, and whose existence we did not know about until a geneticist sequenced a fragment of finger bone in 2010. They left the needle. They left 4 to 6% of their genome in the people of Melanesia. They left a gene for altitude survival in the people of Tibet. They left, possibly, techniques and knowledge that passed into Homo sapiens populations through the interbreeding that the DNA confirms happened. What they did not leave is a record of themselves. The first designer in history is anonymous. The first engineer of thermoregulation has no name. The species that made the most ancient sewing needle ever found existed for hundreds of thousands of years across Asia and left almost no physical trace. And then we found one finger bone and one needle, and it turned out that some of what they were is still in us. The question this video just opened, what it means for a mind to design, to intend, to solve a problem that hasn't killed it yet, was the subject of a formal scientific declaration signed in Cambridge in 2012. The conclusion the scientists reached is stranger than the question. It's right there when this ends. The seam holds. The hand that first made it is gone.